Thank you, Aman. So the next conference to see how harassed you feel is going to be in Pajara. And so, Professor Obuchi, may I ask you to make the presentation?
Could I use this? Well, thank you so much for inviting me, and I would like to thank Professor Desai for this great invitation, and also JICA for sponsoring me to be here. I'm from University of Tokyo. I'm very humbled to be here with all these amazing professors and director of universities. Uh, I just realized that I'm perhaps the only one that not directly related to this whole Indian design conference from the very beginning. So my talk could be slightly off, so perhaps you can bear with me. Today's talk, I would like to talk about prototyping architecture. I study architecture, I teach architecture, I study architecture, and I teach at University of Tokyo. The reason I wanted to talk about prototyping is it's not really for a particular client that we have or particular purpose we have, but simply the testing idea, and that's what we call the prototyping. And also, I think there's some talk about this issue of student. Instead of talking about what the possibility of design can be and what a benefit of the design, I'd like to focus today on what we do in this for whom, and particularly for the issue of students. So towards the creative research and learning environment. The reason I thought I'm going to talk about this is more I go up from assistant to associate professor, more I go up in this ladder, I feel like being a cheerleader. How to motivate students, how to get money from the government or the grants I get, all those things I have to inspire people to do things. So less to do is what we do, but how to create an environment through which a lot of thinking can be done. So where does the creativity come from? That's the main concern that I have, particularly for the student. And how can we learn to be creative? And lastly, how can we teach creativity? It's a possibility. Since this talk is only 8 minutes, so I'm just going to get to the answer, and I was a little bit worried that we're not getting to the end of it. So I'm going to get to the end of it and then see how I can explain that. So uh, the guiding, not teaching, I think this is what I learned. If I try to teach, they resist, just like my kid. If I try to teach my son, he just doesn't want it to be taught. So I have to be really teach in a way to inspire how fun the learning can be. And same thing for even PhD student. I have to guide them, not teaching, and teach advanced tools. And I really recognize that you cannot just tell them what to do in a very abstract way. So you have to teach them what tools available, particularly for the digital technology, computation, as well as advanced a digital tool. And the third thing is make a problem, not solution, and that's what I always do. It sounded kind of peculiar, but the purpose of making, as I said the early, prototyping isn't to make some sort of solution, but identify what series of problems we are facing when we try to make things. The purpose is to make a problem and then find a way to perhaps solve the problem in the most creative way. And lastly, for the student, is meaningful challenges. I think a lot of students, particularly in Japan, the purpose of learning is to go up in the higher ladder of society other than trying to become meaningful. So what they do are socially meaningful, academically meaningful, as well as personally meaningful. And those are kind of things we try to teach, particularly my lab at the Tokyo University. Uh, Before I came to Tokyo University, I was teaching at the School of Architecture Association London for 9 years. This is a school that, for those teach architecture, probably know the very well known experimental architectural schools in London. And what I learned from them is what I just have said. It's not really about solving a problem, but rather try to address the issue in the most challenging way, most creative way. And I was director of this lab. It's called Design Research Lab. And one thing that we try to do at this lab is how to change the way that we approach to design studios. So instead of semester-based studios, we decided to do entire. This is full semester, 18 months a graduate program. Instead, we do chopped up to small exercises. A student will come and get to do only one project for entire 18 months. So what they will do is start it with a very simple, oftentimes bad idea. But if you do a bad idea with only, say, 13 weeks project, you never get to the good project because you just don't have enough time. But if you have 18 months to work on a bad project, and in the end, it all becomes really good. So how to really keep developing idea throughout the entire period of time. That's one thing we did. And the second thing we try to do in this is instead of try to work individually, try to work as in a collaborative environment. So learn from the peer instead of learn from someone like us, an instructor. So students are cross-disciplinary way within the team and try to develop ideas. So that's what I did at the London Architectural Association for about 8 years and tried to develop the idea even further at the Tokyo University. This is some of the images. The reason perhaps I should say that I left London was that digital technology became so good that we can kind of convince ourselves that we can change society on, of course, the screen, on the digital screen. So I need to have more creative, definitive criteria through which those ideas can be tested at. And I'll show you later on, but then move from digital to analog in a much more physical domain. So this is my lab in Tokyo University. I started 3 years ago. The great thing about Tokyo University, I think a lot of things here at IIT the same way. It's an engineering school. Typically, architectural school is architectural school, separate from engineering. But in Tokyo University, it's similar to here. It belongs to the engineering school. It's very vertical. I think you guys call here silos. They don't talk to each other. They're really good at what they do. So what I try to do is not try to make talk to each other because they just don't talk to each other. It's very difficult to do. But creating a project that's a student-led project and then let professor to deal with them. And that's it's possible because there's one single project that everybody's interested in, they like to participate, as opposed to artificially create an environment where they have to talk to, which they don't. And let me just quickly go to the project I'm working on. There are two types of projects. One is called architectural prototypes, and second is urban prototypes. Architectural prototypes is the prototype that very much to do with architectural discipline. Forms, geometry, spaces, those are kind of things that really makes architects really excited about and what possibility of those forms in relation to how people live and how people experience and feel. And using that as a basis and apply that in urban prototype, which is to do with how those forms and architecture function within a larger scale of society in the urban context. So environment, economy, politics, policy, these are kind of things that shape the urban context. So let me just get into a little bit more detail of that. This is the pavilion project that I did in London just before I left and went to Tokyo. The idea here is how to make a student curious about what they do. So the problem that I gave the student is this is made of concrete. It doesn't look like a concrete. A concrete is supposed to feel, oh, it's over 6 minutes. Okay, concrete is supposed to feel solid, strong, cold, and but the exercise we gave us how do you make a concrete feel light, feel warm, feel something very delicate that you don't really experience in normal context. So student worked on a project, developed this particular material, worked with industry, how the thin concrete can be, and how to put together to create this delicate pavilion. And once again, pavilion has no function other than testing ideas. And this is the pavilion that we built right in front of the school in AA in London. Similar thing that I tried at the Tokyo University, creating a geometry, and this particular case is how to use a material which reacts or responds to the heat. So when you heat it, it shrinks, it creates a particular geometry, and this is keep heating it and then become a structural, and in the end, tested in an urban context how that could become urban furniture. But more I try to work with those materials, realize there's limited in terms of technology. So going back to very medieval practice of how to bend steel, so we try to accommodate advanced technology in terms of fabrication in a later project. This is another project which is called circle packing. The creating geometry was quite difficult, so we thought, is there any way that organizing a little tiny bamboo, this ring, and using similar material which is responsive to heat, when you apply heat it shrinks, can you make a space and also structure in the same way? So the student work on it, and once again, these are all nothing to do with creating a beautiful form, but creating series of problems which they can evolve and develop for their larger project to come later on. So those are the structure that we built. Um, and once again, in the end became very hands-on, which is nothing to do, nothing wrong with it, but at the same time we try to address if any way that digital technology could address these making forms in geometry. The next project, this is instead of working on the project only in our lab, how do we engage with the local industry? So this is manufacturing industry just outside Toyota factories in Toyohashi, Japan. When the economy goes up and down, a lot of fabrication shop around the Toyota factory, they lose a job. They have this great machine, they don't know what to do with it, and Japan has the most advanced in terms of use of robotics arms for various manufacturing, but not being maximized in architecture. So we contact them and say any way that we can build using their manufacturing capability for our purpose of lab, because we can't buy these things in our lab for just, it's not that cheap at this point. So this is a pavilion that we're building right now, using this technology that's available locally, but it hasn't been maximized. We joint venture with one of the big construction companies called Obuchi to develop this as a joint venture between industry and educational factor. Using simulation tools to figure out what the structures as well as spaces are being organized, and students are currently working on. So this robotics arm allows to cut a weld and all that in one go. So how do we use these advanced digital technology into fabrication in our project? And once again, all of those are not really to do with how to build project, but also how to identify a series of problems. And the one thing that we found, I think what we're facing is the role of architects has shifted from designing to almost designing so precise that whatever you draw, that's what you manufacture. So there is no tolerance between the drawing and the fabrication. Uh, I'm just going to go very quick because I'm running out of time. So how does those previous pavilion projects are very much architectural discipline. I mean, how does it really work in the city? So this project, this is the last project I'm going to show, is architecture seems to be the more you build, the more pollute the city. The ground becomes more polluted. In Japan, the lifespan of buildings is about 10 to 15 years. That's how the buildings being constructed, demolished, constructed, demolished. This is almost like buying a car. So the more you build, of course, the more you're polluting the land. So is there any way the architecture reverse that? Meaning, the more you build, the cleaner the land becomes. Is that possible to build in that way? So this project deal with us, of course, interested in geometries and form, which is the brick. That is what you're looking at the right. So when you stack them, instead of stack it straight, this is the brick that deformed. So it becomes all the curvilinear geometry. So students are developing particular way of assembling these bricks, but at the same time, how these bricks could operate within the city to clean rather than to pollute. So I'm just going to quick skip that. Get to this point that creating this brick out of this highly polluted, but applying micro, which allows the brick to be clean as they build. So this particular project is using toxic soil as a resources as opposed to unwanted material and use it in a way that the building bricks allow them to purify, but at the same time use this as some sort of temporary structure as a pavilion and use that as a way to clean. So many of the projects I'm working with students right now is how those waste or unwanted material or a result of the industrialized processes created these pollution, but not unwanted, but how do you turn that into a potential resources? So this is one project, the toxics, and also the waste, and also the sewage, and a lot of things that we try to clean them, but in our lab try to see that as a potential resources to create a different kind of architecture. I'll just keep it there. Thank you.